Hello, everybody, and welcome to my presentation. I'm Dennis Becken, and I will be covering the network of Scholars database. Here we have a database design web on the front page. So let's look at the problem and solution. The problem is that many of us have issues at the workplace. We don't know how to do a certain task, and so what we do is we sit there and pull our hair out and bang our heads against the wall until we kind of figure out how to fix the problem or to find a solution to the issue or to finish the task that we have been given by our bosses or higher ups. So what can help us in this situation where we don't know what to do? Well, we can have a database that provides increased production, outstanding worker recognition, and versatility in information. A reference database with all the information that we need to do these tasks and accomplish them because, we're not the only one who had to accomplish these tasks. Of course, there were engineers and engineering managers and, other people that were in our place before that had done similar tasks. And so we need to have a database and a system that is in place so that we know how to accomplish these tasks if we are given these tasks. So let's look at the implementation. As of right now, I decided to use Microsoft Access with a database here that has everything that we need for any given work that we can reference. So we have the number, the field, the subject, different authors, their badges and accolades, the location in the work, the medium, whether it's a book or a thesis or an article, and we have the link to the work so that any worker can follow this and based on the information provided, decide that this is a work that they can reference to accomplish the task that they want to accomplish. Here at the bottom, we have our eventual goal, which is to integrate it with Teams, to either put it as an Access file on there or to have it as an Excel file. We can easily migrate that over with a quick copy and paste. Or another option is to have a website or a social media so that this kind of database can be used in multiple workplaces, not just our example utilities workplace or any other kind of STEM workplace, such as a hospital. We'll get into that later. So let's look at one of the benefits. One of the benefits is increased production. So here we have the Tim Wood production waste acronym: transportation, inventory, motion, weighting, overproduction, overprocessing, defects. This is something that's used in manufacturing, and it's something that we can look at to see where waste is being put into the system that makes it take longer to mass produce goods or to produce goods in general. This is not really something that is for just engineering office work, but it can be applied to it because a lot of the same wastes are present in office production or office issues where production is not being met. A lot of the issues in an office setting come from waiting. We have a task assigned, then we start waiting for a senior engineer or one of our bosses or someone to ask so that we can figure out if there's some kind of reference lying around that somebody has done previously for a similar job, or if there's something online that we can look at that can tell us how to accomplish this job better. One of the biggest ones these days that people reference is AI, but as we all know, AI has some issues because sometimes, for example, with calculus or with mechanics or statics, what it provides is incorrect. So we want to have a reference database that can cut out that weighting and give us important things like the formula for inductance of a transmission line or the surface impedance of a metal line so that we can design that transmission line or that transformer if we're doing that kind of job so that we can go out in the field and maintenance those or put new transmission lines or power lines in without waiting. And so this can help us increase production. Let's look at practical database use case examples. So here we have a ADS or Advanced Design System CPW transmission line design schematic or a coplanar waveguard transmission line. This has a number of different parameters. As you can see here, we have W, G, and L, and we have T, which is for period, and we have different frequencies for our S parameters. We have 50 megahertz start, 50 gigahertz stop, and 50 megahertz step. So if we don't have these parameters or any of this information, also this happens to be a 50 ohm transmission line design, we may not know how to do this, and this may take a lot of calculations and more over processing and overproduction than we need to, especially if we have this kind of reference, or we have a specific reference that's from our office from a senior engineer who had designed something similar. It's kind of that old adage, if it ain't broke, don't fix it. We don't need to do a new design if we have a previous design that we can look at. And when you're working in the field of engineering, as we all know, a lot of the designs that you make are not owned by you, they're owned by the corporation. That's something that you sign off on when you sign a contract. So it'd be great to have these previous designs on file somewhere so that junior engineers and new hires can look at it when they first start a job. So another benefit is outstanding worker recognition. So we want to provide an open platform through Teams or through that website or database, as I said. And this can help us give workers a place to contribute to the works that are in the database. Here we have an example of a transformer design schematic. People can have works that are published or from different university databases that they share, or through Google Scholar, or just works that are through Google Docs that they can share the link to, that has their works and their designs that have worked in the past, so that new hires can have something to reference when they go to tackle difficult tasks like designing a transformer, designing transmission lines, or designing power lines. And this can lead to increased production and less opportunity for damaged or destroyed materials in use cases where things can be put in place and built that have not been tested extensively, either through simulation on programs or through extensive calculations. And so basically the idea is that we can award expertise badges to people who have contributed lots of great works to the system, that have worked for many different engineers. We don't want to award people who are just producing a lot of material that isn't really helping much. We want to award those that produce just a few great jobs, or even many great jobs that have helped many engineers in the field accomplish tasks. So let's look at another benefit. Another benefit is versatility. So we looked at in the research for this a database in Sweden called the DDB, or the Demographic Database. And this was a database that was designed by the Umeå University in Sweden, the Center for Demographic and Aging Research, or the CEDAR. Their information covers many different subjects: sociology, statistics, economics, medicine, history, cultural studies, and it even extends to religion and lifestyle. This is not surprising considering this is for a university, so it needs to tackle many different fields. Our system, the Network of Scholars Database, or NOSDB, has an information theme which is based on STEM. So we want to have electrical utility design, as I mentioned, vehicle maintenance, so that people can go out in the field without having issues with their vehicles, and they can take care of that in the office. And healthcare scenarios. For example, one scenario that I came up with while doing research and thinking about the project was for PAs. PAs are physician's assistants. So we want to provide a way for physician's assistants to get information on how physicians do jobs, just in case, for whatever reason, there's a shortage of physicians and there's a lot of patients in the hospital, or if in cases like the pandemic where we have an increasing amount of patients and not enough doctors to see them. So in conclusion, we have the DDB development timeline and the NOSDB development timeline. As you can see, it took them 50 years to develop the DDB. And so in order for us to have our own database with a website and all those fancy and advanced things, we need to have more time. But we do have a database set up, and we want to extend some of the strengths of the DDB to the NOSDB. For example, data that's traced back to the source, also research-oriented data processing and coherent, consistent data. And our database provides an estimated increase in production of 15 to 30%, error reductions of 25 to 50%, and a training time reduction of 40%. So this is great, and this helps us accomplish our goal. Thank you so much for listening, and here are my references. Have a great day.